Hi everyone. Today we're going to be looking at creating a system of equations from context and then taking that system of equations and solving it graphically. We're going to be looking at three different types of examples today. So the first example we're going to look at is where both equations of the system are going to be in slope-intercept form. Then we're going to look at another example where one equation is in slope-intercept form and the other one is in standard form. And then finally, we're going to look at a system where both equations are in standard form. So in example one, Christian's cab company charges a one-time fee of $5 plus 25 cents per mile. Juliana's car service charges a flat rate fee of $1.50 per mile. Write and solve a system of equations graphically in order to determine when both companies would cost the same. Most likely, you remember this problem being represented this way. So Christian's cab company is 5 plus 25 cents per mile, and we use X in this case to represent the number of miles, and Juliana's car service is $1.50 per mile. And then that word the same, you guys know, means equal. So when will the two costs be equal? And then you can simply just solve the equation for x, and you would get x equals 4, which would mean that both cab companies will charge the same amount in 4 miles. If you wanted to find the amount of it, you would just plug in x as 4 into either Christian's expression or Juliana's expression, and you would get 6. The other way of doing this is to represent both as actual equations. So representing Christian's cab company with the equation y equals 5 plus 0.25x, which would mean y would be the cost and x would be the miles, and then Juliana's would be y equals 1.5x. And if you graph them, you'll see that they intersect at the point 46. And in this case, that point 46 would mean 4 miles, and the cost would be $6. So in 4 miles, both cab companies would cost $6. In the next example, Autumn runs a farm stand that sells peaches and grapes. Each pound of peaches sells for $2, and each pound of grapes sells for $4. Autumn sold 35 more pounds of grapes than pounds of peaches and made $200 altogether. Graphically solve a system of equations in order to determine the number of pounds of peaches sold X and the number of pounds of grapes sold Y. So when you're looking at this question, it's good to break this apart and look at everything that has to deal with money first. So if I'm looking at things that have to deal with money here, I see the $2 per pound of peaches, and then I see the $4 per pound of grapes. I know X is peaches, Y is grapes, and altogether it's $200. And then the other equation, it says Autumn sold 35 more pounds of grapes than pounds of peaches. So I know grapes Y is going to have to be the number of peaches plus 35. So I have both of my equations. One of them is not in slope-intercept form, so I would need to change that into slope-intercept form so that I could graph it. So on the next slide, I graphed it, and I can see my intersection point, which is my solution here. So I know that my answer would be 30 peaches and 65 grapes were sold because our x-axis was representing peaches and our y-axis was representing the grapes. And in our final example, Nevaeh has 80 cents worth of nickels and dimes. She has a total of 11 nickels and dimes altogether. Graphically solve a system of equations in order to determine the number of nickels X and the number of dimes Y that Nevaeh has. So I started out with the simple equation first. So X plus Y equals 11. So that basically just came from the total of 11 nickels and dimes, right? X is nickels, Y is dimes. So if you add them together, you get 11. That one is pretty simple. The next one you kind of have to think about because you have to because it doesn't tell you anywhere how much a nickel is worth in dollars. So you kind of have to use that background knowledge for this one. So I wrote 0.05x, which would mean 5 cents per nickel. And I wrote plus 0.10y, which means 10 cents per dime for a total of 80 cents. Both of these equations are not in slope-intercept form. So I would need to change them both into slope-intercept form and solve for y so that I can graph them. So on the next slide, I graphed both, and the intersection point of those two lines was the point 6.5. In this case, it would mean that Nevaeh has 6 nickels and 5 dimes. And if you wanted to go back and check, that would make sense because we said that Nevaeh had a total of 11 coins altogether. So 6 plus 5 is 11. And if you have 6 nickels, that would be 30 cents. And if you have 5 dimes, that would be 50 cents. And 30 cents plus 50 cents would be a total of 80 cents. And that wraps up our